Okay, so this is the cube root function. It can be found in chapter 10.2 in your textbook. The cube root function is very similar to the square root function. So our parent function will be f of x equals the cube root of x. So be careful, the 3 that's in the front does not mean 3 times the square root of x. It is the cube root of x. It's small and it's kind of in that symbol there. Okay, so if I want to fill in this table, to figure out what the graph looks like, I'm going to substitute -8 in for x. So what the cube root of -8 means is what times itself 3 times gives me -8. So that answer is -2. -2 times -2 is +4, and then 4 times -2 gives me -8. Okay, the cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1, and the cube root of 8 is 2. All right, and the graph will look something like this. So if you notice, it kind of looks like the square root function, but it also has a portion that's on the left side as well, and it kind of looks like a zigzag or a S. Okay, so this one goes off in both directions. So the domain for this one, if you're looking at all of your x values, I see arrows on both sides. So it's going to go to the left forever. It's going to go to the right forever. So we're going to go from -infinity to +infinity. Okay, another way of saying that is all real numbers. Okay, it includes everything in between -infinity and +infinity. Our range is up and down. So the lowest our graph is going to go because of that arrow is -infinity. It's going to go down forever. It's going to go up forever as well because the arrow goes to the right and up. So again, it's all real numbers. So you can write all real numbers, or you can write the symbol for all real numbers that looks like that. Okay, our x and our y-intercept, just like in before in our square root function, this one is the same. It is not always the same, but in this case, in the parent function, they both are 0, 0. So before we get into today's lesson, I want to show you how to find graph these on Desmos. It's a little bit hard to find. It took me a little bit to kind of navigate a little bit to figure out where it would be. I know a lot of you will be using this because I don't think you have graphing calculators at home. If you happen to have a graphing calculator, you can hit math number 4 for the cube root. But when you're in Desmos, you're going to open up this keyboard at the bottom, and you're going to go over to where it says functions. All right. At the top, you see we have another menu. It says trig, stats, dist, and miscellaneous, M-I-S-C. And if you go to miscellaneous, you see the nth root or n square root. Okay, that's going to be good for any root. So cube root, 4th root, 5th root, whatever it may be. So I'm going to tell it it's the 3rd root. And under my radical, I'm just going to graph the cube root of x. Okay, so you can see that is what my graph looks like. Square root is next to ABC. So if you want to do the square root, you don't have to open any other menus to get to that. But again, to get to the cube root, you go to functions, miscellaneous, and then click on the one that says n cube root or n square root, the nth root. Okay, so let's go back to our PowerPoint. So this one says, what are the maximum and minimal values for the cube root of x over the intervals -8 to +8? So I want to know, in between those two x values, what's the lowest x value that could be possible and what's the highest x that could be possible. So this is substitution. So I'm going to substitute -8 in first. So if I do the cube root of -8, I'm going to get -2. And then I'm going to do the same thing for 8. The cube root of 8 gives me +2. Sorry about those little extra strands on there. So what that means is -2 is my minimum value, the smallest x value possible. 2 is my maximum, the biggest x value that's possible. And then in between -8 and +8, we could have anything in between. All right, so this is the try it. Go ahead and pause your video, give this one a shot, and come back to check the answers. Okay, so This one, we're trying to find between negative 27 and positive 27. So we have the cube root of negative 27 and the cube root of positive 27. All right, well, the square root of negative 27 is negative 9. Positive 27 is positive 9. So our minimum is negative 9 and our maximum is 9. All right, and also you could write, give me 1 second, let me go back to there. I clicked too many times. You could write you could say that the minimum maximum would be between negative 9 and 9. You could write it that way as well. Okay, so this is a big one. It's just like when we did square root. It's just like when we did quadratics and linears. We're comparing rate of change. So the rate of change formula is y2 minus y1 over x2 minus x1. We use that every single time you see rate of change. Okay. This one we have the function, the cube root of x minus 1. And we want to find the rate of change between 1 and 5 and 5 and 9. And we're comparing the two to see which one is greater. So we're going to do two pieces for this one. Let's do x equals 1 and x equals 5. So if I substitute those in, and I say the cube root of 1 minus 1, I'm just substituting in x equals 1. Well, that's really the cube root of 0, which is 0. Okay, then I want to compare to the cube root of 5. So I'm substituting 5 in. Well, 5 minus 1 is 4. So really we have the cube root of 4. Well, the cube root of 4 is 1.59. Okay, so when I substituted 1 in for my x, I got 0 for my y. When I substituted 5 in for my x, I got 1.59 for my y. So we can go ahead and label our parts if you need to. If you don't need to, you don't have to worry about it. All right, remember my first point gets 1s, my second point gets 2s, and each one gets an x and a y. So y2 minus y1 over x2 minus x1. So 1.59 minus 0 is 1.59. 5 minus 1 is 4. And if you go ahead and divide that out, let me look at my paper here, I get 0.40. Okay, or something close to that. It might be depend on how you round. Okay, and then we're going to do the other set. So the good thing is we already did x equals 5. I know when x equals 5, my y is 1.59. So that's one less that I have to do. But I do have to take care of this x equals 9. So if I do the cube root of 9 minus 1, which is the cube root, of 8, the cube root of 8 I know is 2. So in this case, when I plugged in 9, I got 2 as my answer. So let's go ahead and do our rate of change formula. So you can, again, write them out if you need to. I'm not going to write them out this time. But my y2 minus y1 over x2 minus x1. Okay, so 2 minus 1.59, and then 9 minus 5. If I go ahead and do that, I end up with 0.10 as my final answer. And then we're going to compare these two. So which one of those two numbers is bigger? So if you look at the tenths column, I have a 4 on the left and I have a 1 on the right. So therefore, the left one is greater. So you can either use your inequality symbols or you can write a sentence and say the average rate of change between x equals 1 and x equals 5 is greater than when x equals 5 to x equals 9. All right, so here is a try. Go ahead and pause the video and come back to check the answers. All right, so this one, be careful. This one is our function here, and that 2 in the front is multiplication. So this says 2 times the cube root of x minus 3, okay? And unfortunately, we have to do all 4 numbers for this one because they're all different. We didn't have any duplicates like we did in the last one. So instead of going through and writing the cube root for each one of these, I'm just gonna go ahead and give you the answers for when we substitute our values in. When I substituted in negative 12, okay, let's see. I got negative 4.9. When I substituted in negative 8, I got negative 4.45. When I substituted in negative 4, I got negative 3.83. And when I substituted in 0, I ended up with negative 2.88. So again, depending on how you round, you should get something similar to what I have here. Now, we can think of these as ordered pairs. So the first line are my x's and the second line are my y's. So first we want to compare these two. So we're going to use that rate of change formula. So we have negative 4.45 minus negative 4.9 over negative 8 minus negative 12. Now notice how on the top and the bottom I have double negatives, minus, minus. So right away I'm going to change them to plus, plus, and same thing on the bottom. Okay, so if we go ahead and do this, we do 4.45 plus 4.9 divided by negative 8 plus 12. You should end up with, 0.1125. And you can round it to whatever decimal place you want. I would go at least 2 decimal places past the decimal point. All right, now we want to compare these two. So again, my y2 is negative 2.88 minus my y1 is negative 3.83. x2 minus x1. And again, double negatives, I'm going to make them all positive. So when you go ahead and you solve this, you should end up with 0.2375. All right, so we want to compare these two. So remember, when you're comparing decimals, you need to look by place value. So over here, if I look at the tenths column, I have a 1. And if I look at the tenths column over here, I have a 2. Since 2 is greater than 1, I can say that this one over here is greater. So the average rate of change is greater between negative 4 and 0 than it was between negative 12 and negative 8. All right, so for this one, we're comparing rates of change of 2 functions, okay? They give us function g, or g of x, is our graph, and function h of x is our table. These are not the same, okay? The one that's on the table is the cube root of x. The one on the graph, if you notice, our intercept is not at 0, 0. Okay, see how it's been shifted to the left 2 spaces? So this one actually represents g of x equals the cube root of x, and since it's shifted left 2, you have to add 2 on the inside. So what I did was, it's really, really hard to tell from this graph. It's a really bad graph, okay? What they want to know is between 2 and 4, which one has the greater rate of change, okay? So if I go to x equals 2 on my graph and I go up to where the line is, it's right there. If I go to 4 and go up to the graph, it's right here. I can't tell what those ordered pairs are. I know that they're both, if I look at my y's, they're both between 1 and 2, but I'm not sure exactly what they are. So what I recommend doing is going to Desmos and looking at the table. So when you type in the cube root of x plus 2, you're going to see a gear symbol. If you click on the gear, then it'll allow you to look at the table, and you can look at the values of 2 and 4. So if you go in there and you look at the table, you will see me flip pages here. For g of x, when x equals 2, y equals 1.59. And when x equals 4, y equals 1.82. And you may have to type in the table 2 and 4. I'm not sure how far down it defaults to, so you may have to keep on adding numbers to your x's in your table and it will add more y's in. All right, and this is an 8. Sorry. Okay, so if you do, again, x1, y1, x2, y2, and we're going to subtract 1.82 minus 1.59 over 4 minus 2, and you should get 0.115. That's the rate of change between there. It's very, very minimal between those 2 points up here on the graph. Now over here for our table, we're going to compare. I'm looking at the order pairs that are here, okay? So this would be my first point. This will be my second point. So I would have my y2 is 2.81 minus 2.48 over 4 minus 2. And if you go ahead and you solve that out, you should get 0.165. And then we're comparing these two. So which one has a greater rate of change, the graph or the table? So again, look at your ordered, at your place value. So this one I have a 1, and this one I have a 1 in my tenths. They're the same. So then you go to the hundredths. This one has a 1 in the hundredths. This one has a 6 in the hundredth. 6 is bigger than 1, so therefore the table has a greater rate of change between 2 and 4 than the graph. Okay? All right, so for this one, you need to do the classwork, which is on page 422 to 423. Problem numbers 4 through 8, and then 16 through 19. And then the exit ticket is page 423, numbers 10 and 11. So remember, you can send them to me via Schoology, or you can submit them by email or through the drive, whatever is easier for you. If you're better at doing it on paper, you can snap a picture and then send it to me. I'm also available on Blackboard Collaborate between 9:30 and 11:30, and then 1 and 3 every day. So you can always pop in and ask questions, or if you want to see some more examples, we can do that.